Everyone, welcome back. Just try this question. So this question says that a window is held open by chain AB. Determine the length of the chain and express the 50-pound force acting at A along the chain as Cartesian vector and determine its coordinate direction angles. So this question demands us that we are going to find out the length of the AB cable. So I'm going to write that is RAB vector magnitude. This is the first thing we are going to find out. And another thing is that we are going to convert the magnitude form of force, which is equal to 50 pounds, into the Cartesian form. So it is nothing but the vectorial form of force. And the last thing is that we are going to find out the coordinate direction angles, and it is nothing but the alpha, beta, and gamma. So these three things we are going to find out in this video. So without any delay, let's start. So for finding out the values, we are going to start from the very basic thing, that is to find out the locations of every single point present in our diagram. So if you carefully look at the diagram, so there are the only 2 points. One is point A and the another one is point B. So find out the locations of these 2 points. So let's start from the point B. Okay, so this is basically our point B, and the point B, it is basically lie on the YZ plane. It's mean that there is no X value present in point B. So the location of point B, it can be written as B bracket 0 comma this 5 foot distance, it is nothing but the positive Y value present in point B, and this 12-foot distance, it is considered to be the positive Z value present in point B, because this 12-foot distance, it is indicating vertically upward, that's why. And this 5-foot distance, it is indicating on the right hand side, so that's why they both are positive. Okay, so the location of point B, it is nothing but 0 comma 5, and the Z value, it is nothing but the 12 bracket close. This is nothing but the location of point B. Now what about the location of point A? So if you see carefully, the point A, there is the angle mentioned here, that is the 40 degree, and this 40 degree angle, it is basically measured from the positive x-axis. So if you see that, this is basically our positive x-axis according to the equation, the red one. Okay, the red one. I think there's so much mess here, so I'll draw it again. So this is basically our positive x-axis. Okay, and this angle, it is basically 40 degree measured from the positive x-axis. So by the help of free vector, if this is positive x-axis, this is also positive x-axis. Okay, we know about it. So the vector A makes an angle 40 degree from the positive x-axis. Okay, this is the point number one. Another thing is that, and another interesting thing is that this length right here, this one, the purple one, is already given to us in our question diagram. If you see that, so this 5-foot distance, it is basically this length. Okay, so what about these two lengths? So what about these two lengths? One is this length, the purple one, and the another one is this length, the red one. So the red one length, it is nothing but the positive z axis, because this length is indicating vertically upward. Okay, and this length, it is basically given to our question diagram. Okay, so if you see that, this is basically our point O. Let me erase some extra thing from here because the mess is created here, that's why. So this is basically our point O. Okay, this is basically our origin, and the distance measured from the origin to the point O, it is nothing but the positive Y value distance. Okay, and if you see the question diagram, so this 8-foot distance, this one, it is representing the positive Y value in point A. Okay, so we only need to know the two values more, that is the positive Z and positive X. Okay, so this is nothing but our triangle. Okay, and if I'm extracting this triangle into here, so it may be draw like this, and this is nothing but our right hand side view of this triangle. Okay, this is basically our 40 degree angle right here, measure from the positive x-axis, so it is our positive x-axis. This is nothing but our positive z-axis, and the angle between any two axes, it is known as 90 degree, and this is basically our 5-foot distance according to the question. Okay, so apply the sine theta and cos theta function here to find out the value of x and z here. Okay, so we know that sine theta, which is equal to perpendicular upon hypotenuse, the opposite side of theta, it is known as perpendicular, and in this case it is nothing but the positive side. And where the two angles meet each other, so that particular side are known as base. So x, it is our base, and the opposite side of 90 degree, it is nothing but our hypotenuse, and in this case it is nothing but the 5. So theta, it is nothing but the 40 degree here, okay, and the perpendicular, it is nothing but again z, and the hypotenuse, it is nothing but 5. So z, which is equal to 5 into sine of theta, and theta in this case it is nothing but the 40 degree, because 40 degree, it is basically the angle measured from the point A to the positive x-axis. That's why. So sine 40 degree into 5, so it gives us a result of 3.21 foot. This is basically the positive z value present in point A. And again, apply the cos theta function here. So cos theta, which is equal to base upon hypotenuse. Okay. So again, base in this case, it is nothing but the x, and the hypotenuse, it is nothing but the 5. So x, which is equal to 5 into cos of theta, and theta again, it is nothing but 40 degree. So x, which is equal to, so cos 40 degree into 5. So it is equal to nothing but 3.83 foot. Okay, so we successfully find out the z and x value present in point A, and the y value, it is already given to us in the question, that is nothing but the 8 foot. Okay, and these all are the positive values. Okay, so the location of A point can be written as, if I am erasing some extra thing from here, so this is nothing but the location of point A, and in the B point, I'm sorry, I forgot to write down the unit, that is nothing but the again foot. Okay, so we successfully find out the locations of every single point present in our diagram, and if you have any confusion regarding to find out the locations, please comment me down on this video, and inshallah I will reply you. Okay, so don't worry. Now we find out the location of A and B point. The question demands us that to find out the length of the AB chain. Okay, so this length right here, the yellow one, we are interested to find out this length. So before we are going to find out this length, firstly we need to find out the position vector. Okay, and if we take the magnitude of the position vector, so we find out the magnitude of position vector, and the magnitude of position vector represents the length of the AB cable. Okay, so what about the position vector? So the head of this 50-pound force, if you see the equation diagram, so this is basically the head of 50-pound force. So the head of 50-pound force is directed towards the B point. It's mean that B point is the final point and A point is the initial point. So the position vector of these 2 points can be written as RAB, which is equal to the RB minus RA. Okay. The location of B point, we know about it. It is nothing but the 5J, positive 12K. And again, the location of A point, it is nothing but the negative 3.83Y cap with negative 8J cap with negative 3.21K cap. Okay, so rearrange this thing. So it could be written as negative 3.83I. So add 5J with negative 8J. So it is equal to negative 3J. And lastly, add 12K with negative 3.21K. So it is equal to positive 8.79 K cap foot. Okay, this is the position vector, but what about its magnitude? For the magnitude, we have the formula, that is RAB magnitude, which is equal to under root x square plus y square plus z square. The value of x, it is nothing but 3.83 square. The value of y, it is nothing but the 3 square, and the value of z, it is nothing but the 8.79 square. So if the question arises in your mind is that why I don't write the negative sign here? Okay, because the square above this negative sign will convert automatically the negative sign into the positive sign, so you don't need to write it down here. Okay, it's completely fine. So take the calculator, put the values into it, and solve it for the magnitude of the RAB. So the magnitude of the RAB, it is nothing but the 10.04 foot, and the magnitude, it is always a scalar quantity. Okay, because magnitude, it is nothing but a number, and in real life number can never ever be negative. Okay, that's why. So our first agenda is completed, that is to find out the length of the chain. Okay, so if you see the question statement, so the yellow one, which we already found out. Okay, so you don't worry, that is the length of the AB chain that represents the magnitude of position vector we found out. Okay, that is 10.04 foot. So let's move to our another step, that is to convert the 50-pound force, the magnitude of 50-pound force into the Cartesian form. So without any delay, let's start. Now let's move to our second agenda, is that to find out the Cartesian form. So let me tell you something, that if you have the magnitude form of force and where is the actually force acting, okay, so if you have these two things, you are easily find out the Cartesian form. How? Let me explain you. So the vectorial form of force F, which is equal to the magnitude form of force F into the unit vector. What is unit vector here? The unit vector represent here where is your actually force is acting. Okay, so if you see the question diagram, your force is actually acting the AB segment. Okay, and for the AB segment, you have the position vector of AB as well as the magnitude of position vector of AB. Okay, you are easily going to find out the Cartesian form of force if you have these two things. What is that? These two things, one is the magnitude form of force and the another one is that where is your actually force is acting. Okay, so the magnitude form of force, according to the equation, it is nothing but the 50, and the unit vector, it is nothing but the position vector, that is the RAB, because the your force is acting on the RAB. That's why the RAB position vector divided by the RAB position vector magnitude. Okay, so 50 into the RAB position vector is nothing but the negative 3.83 I cap. Okay, so negative 3.83 I cap with negative sign 3 j cap with positive sign 8.79 k cap divided by its magnitude, that is the 10.04. So again, the thing is easy, that is the vectorial form of force F, which is equal to 50 into negative 3.83 and divided by 10.04. So it gives us a result of the negative 19.07 I cap. Similarly, 50 into negative 3j and divided by 10.04. So it gives us a result of negative 4.68 j cap. And lastly, 50 into positive 8.79 k cap and divided by 10.04. So it gives us a result of 43.77 k cap, and don't forget to write down the unit, that is the pound. Okay, so this is basically our the Cartesian form of force F. Okay, now our second agenda is completed, that is we found out the Cartesian vector, okay, of force F. Now the last thing is that you are going to find out the coordinate direction angles. So let me erase some extra thing from here. Now for finding out the coordinate direction angles, we have the formula, that is alpha, which is equal to cos inverse fx upon f. The value of fx, it is nothing but negative 19.07, and the value of f according to the question, it is nothing but the 50. So negative 19.07 divided by 50, so it is equal to negative 0.3814, and if you take the cos inverse of this value, so it is nothing but the 112.42 degree. Okay, again the beta, which is equal to the cos inverse fy upon f. Okay, so cos inverse the fy, the value of fy, it is nothing but the negative 4.68, and the value of f, it is nothing but the 50. So negative 4.68 divided by 50, so it is equal to negative 0.0936, and if you take the cos inverse of this value, so it is equal to the 95.37 degree. Again the last one, that is gamma. So gamma, which is equal to cos inverse fz upon f, the value of fz, it is nothing but the 43.77. Okay, so cos inverse 43.77, and the value of f, it is nothing but the 50. So 43.77 divided by 50, so it is equal to 0.8754, and if you take the cos inverse of this value, so it is equal to the 28 degree, 28.90 degree. But the important thing is that what this value represents here. Okay, so alpha, which is equal to 112.42 degree, it represents that your force F is making 112.42 degree from the positive x-axis. And similarly, the 95.37 degree represents here your force F is acting, your force F is making 95.37 degree from the positive y-axis. And the lastly, the 28.90 degree. This value represents that your force F is making 28.90 degree from the positive z-axis. Okay, so your question has been solved here and your concept too. So please like, comment, subscribe and share it with your friends too. This is Khalil. Take care of yourself. Allah Hafiz.